Hello and welcome to today's daily Leetcode challenge. Let's solve question 802. Find eventual save states. So there is a directed graph of n nodes with each node labeled from 0 to n minus 1. The graph is represented by a 0-indexed 2-integer array graph, where graph index I is an integer array of nodes adjacent to node I, meaning there is an edge from I to each node and graph of I. The node is the terminal node if there is no outgoing edges. The node is safe node if every possible path starting from that node leads to a terminal node or any other safe node. Return an array containing all safe nodes of the graph. The answer should be sorted in ascending order. Okay, so let's recap in my own words. We are given a graph, a direct graph, and there is a notion of a safe node. That safe node is one from which, there is a terminal node. There's two types of nodes, actually three. There's a terminal node, which basically means that there's no outgoing node from that terminal node. There's a safe node, which means that it's either its neighbors or it's pointing to other terminal nodes or other safe nodes. And then there is an unsafe node. Okay, so there's three types of nodes: terminal, safe, and unsafe, and we have to find all the safe nodes. Safe nodes are actually, everything can be broken down into not safe and safe nodes. So terminal nodes are part of the safe node. Let's see. So basically any loop within here would be an unsafe node. Let's try to find if there's a loop. 0, 1, 1, 2, 2, 5. 5 is a safe node. 4 is a safe node. 6 is a safe node. Is 3 a safe node? 3, 0, 1, 3. So between 0, 1, and 3, there's a loop. Is 2 a safe node? 2 only goes to 5. So 0, 1, and 3 are not safe nodes. Everything else is a safe node. 0, 1, 3. So 2, 4, 5, 6 are safe nodes. Okay, so I think I understand. Any other examples? This example is going to be hard to see. But what this really means is there is 1, 0, 2, 3, 4 nodes, and out of those 4, there's 5 nodes. And out of those 5 nodes, only the fourth one, 0, 1, 2, 3, 4, is safe, because between these, there's a loop everywhere. Okay, so I think I understand how this would be done. There must be a modification to the deep first search algorithm that would land us in a pattern where we can be doing the DFS and simultaneously updating something called, I guess, a safe, maybe like dictionary, where if we've decided that a node is safe, we mark that as something safe. If we mark a node as unsafe, we mark it as unsafe, and then use that dictionary to later find if some node pointing to that node is safe or unsafe. So let's define this dictionary. And essentially, we're going to have something like an answer, I guess, list, and say that for node in graph, oh no, this is going to just be range of length graph, we're going to say if node, if DFS. We haven't defined DFS yet, but we are going to. If DFS node, then answer append node, and then return answer. Now we have to define the modified version of DFS. Let's define that here. Def DFS. Okay, so what is this? How is this going to work? We have a node. Well, right off the bat, if we already know that we've seen this node and we've marked it as either safe or not safe, we can have a condition that if node in safe, then return safe node. Else, we actually have to dive deeper and look at and continue the deep first search, which means that traversing all of the children of that node. So for neighbor in graph node, we're going to say that for every node, we have to find we have to do DFS, right? So would it just be DFS neighbor? I guess that if not DFS return false. So we would actually be doing DFS and making an assumption for our own node. So if one of the, so basically here, if at least one of our neighbors is unsafe, return false for me, for current. And then yeah, and then I guess if none of the children are unsafe, then we can return true, right? So the assumption here is that if none of the children are unsafe, we must be safe. Sorry. Okay. Oh, and you know what? Yeah, maximum recursion depth exceeded because we have there could be a situation where we are looking at a node that is in that loop 0, 1, 3, and then 3 pointing at 0. So let's set safe temporarily of node to false, and then actually if we already got to this point, we are true. So this should work. Unknown network error, and actually I'm getting some outages. Submit. There we go. Cool, and we are 71 percentile, which is not bad at all. It seems like I've tried this question a while back, actually. So yeah, okay. Well, again, just to reiterate, this is a modification of the DFS algorithm where we are diving deep into our connected graph and looking consistently at our safe table, our safe dictionary that actually tells us if the node that we have already seen, and this is another version of the scene data structure that keeps track of something that we've seen. If we've seen this, then return. If not, if this is something new, then dive deeper, figure out if the node is safe or not. The only instance that absolutely 100% makes it not safe is if one of its children is unsafe. So if not safe, then absolutely return false. But everything else, which is that either a child is safe or a child has not been seen, does not yet guarantee that the node that we're looking at is going to be safe. So yeah, let me submit this one more time, see if any improvements. Yep, I mean, not 90th percentile, but seems to be working fine. And this is a very concise, very easy to read approach, so I'd recommend this. Thank you for watching, and I'll see you tomorrow. Please like and subscribe. Bye.